Welcome back. Today we're going to talk about section 9.5, which is really kind of a cool thing. We're going to solve quadratics by a method called completing the square. Completing the square. So if you're paying attention, you'll realize that we skipped over 9.4. Well, that's because we did 9.4 previously. But I'm going to do a quick little review. What 9.4 was all about was solving a quadratic where you only have one term that's squared. And the steps are, if we were going to solve this equation algebraically, we would isolate the a squared. That means get it all by itself. So first we would add 9 to both sides. And we would have 2a squared is equal to 20. Then we would divide both sides by 2, and we would get, going up here, a squared is equal to 10. And then to solve this, we would square root both sides, and we would have a is equal to plus or minus the square root of 10. So we worked on these kind of problems before. We'll use this method again today. What is completing the square? Well, let's do a couple of squaring binomials. Remember that if you have x plus 1 quantity squared, this means x plus 1 times x plus 1. And if we FOILed this, we'd get first x squared, outer is x, inner is x for a total of 2x, last plus 1. If we had x minus 3 quantity squared, first would be x squared, outer is negative 3x, inner is negative 3x for a total of negative 6x, and the last is 9. And x plus 5 quantity squared, the shortcut would be you square your first term, you take the product of the first and the second and multiply that by 2. So 5x times 2 is 10x. And the last term is 25. So looking at these three products, I want to find a pattern here. How is 1 related to 2? How is 9 related to 6? How is 25 related to 10? You could think about that for a minute, or I'll give it away. If you take your middle term, divide it by 2, and then square it, you get your last term. So 6 divided by 2 is 3, 3 squared is 9. 2 divided by 2 is 1, 1 squared is 1. 10 divided by 2 is 5, 5 squared is 25. So completing the square, what we are going to do is we're going to start with a trinomial quadratic. We want to know what must this number be to make this a perfect square, something that looks like this that we could then factor into a perfect square binomial. So this is called a perfect square. All right, this number, remember, is you take the middle term, divide it by 2, and square that, and we would get 16. The second step in this completing the square would be then to write this as a binomial squared. And what do you think this would be? In other words, we're going from this step back to here. Well, we know that this number squared equals that. 3 squared equals 9. 5 squared equals 25. So if we have 16, we would square root that and get a 4. This sign is positive, so we have a positive. So we've done something called completing the square and then factoring to our binomial quantity squared. All right. Half of this squared, and then factor x sign minus, what would this number be? That if you squared it, you got 36. So remember, let's draw some conclusions here. Compare and contrast. This number is the square root of our C, and it's also half of our B. And then here, ooh, this one's a little bit tricky because 3 doesn't evenly be divided by 2. But if we did take half of that, we would have 3 over 2. When you squared that, what is 3 over 2 squared equal to? It would be 9/4. If we were to factor, we'd have x plus, remember, this number is either half of this or the square root of that. And that's this, I call this an intermediary number. That's like the second step of finding the perfect number. Half of B or the square root of C. All right. In general, your C, your perfect number, is half of the B and then squared. Where are the A, B, C coming from? The standard form, y equals ax squared plus bx plus c. So our C, our perfect number that goes here, is half of the B and then squared. C is half of this and squared. And then factoring, oop, forgot my little squared there. Okay. So we are going to use this method to solve quadratics. We're going to solve by completing the square. Alrighty, so we have a quadratic equation. We have x squared minus 16x. Now we're going to leave a space right here for our perfect number. And we're going to leave the negative 15 over here on this side. What number would we have to add in here to make this a perfect square trinomial? Well, the C, first of all, is always positive. We want to take half of this, which is 8, and square root 8. We get 64. Well, if we add 64 on one side, we also have to add it in on the other side. So we've added in 64 to both sides of our equation. That's our first step. First step, add the perfect number to both sides. Can you see that? Both sides of your equation. What's that perfect number again? The perfect number is right here. That's our perfect number. Half of b quantity squared. That's what we add on to both sides here. Now, our second step is we're going to factor that trinomial. We've made it to be a perfect square. What is that perfect square? Well, it's going to be x minus, what number goes here? 8. On the right-hand side, let's just simplify that. Is that 49? All right. Our third step, now we're taking into account what we learned in 9-4. If you have a squared equals 10, what is a? You square root both sides. Square root both sides, and remember we need the plus and the minus when we're solving an equation. We do the same thing here. We can square root both sides. So this is step number 3. Let me put it in a different color. We're going to square root, take the square root of both sides. So if we square root the left, square root the right, our equations are still equal. The square root of a square, they cancel each other out, so we get x minus 8. The square root of 49 is plus or minus 7. Now our last step is we need to solve both equations. What do I mean by solving both equations? Well, x minus 9 equals plus 7, or x minus 9 equals negative 7. Add 9 to both sides, x equals 16. Add 9 to both sides, or x is equal to 2. And I would challenge you, go ahead and put in 16 up here. 16 squared is 256 minus 16 times 16, add 9. That should work out to, try them out. Make sure that this equals to each other. If they don't, then I made a mistake somewhere. I think we're good. All right, let's try another one. This is the guided practice in your book. X squared minus 2x equals 3. We want to solve this by completing the square. So we're going to rewrite this. X squared minus 2x. Leave a little space for your perfect number is equal to 3. And then remember, we're going to add the perfect number on this side also. Now we need to find the perfect number. So we take half of this, which is 1, and square it, which is 1. Whatever I add to the left, I have to add to the right. Second step, we're going to factor this. This will factor into x minus 1, quantity squared. Simplify, 3 plus 1 is 4. Take the square root of both sides. Step number 3, square root both sides. So if you square root a square, you just get the quantity. When we square root 4, since we're in an equation, we do plus or minus 2. And then now we want to solve both equations. So we have, I'm going to put it up here, x minus 1 is equal to 2, or x minus 1 is equal to negative 2. Add a 1 there, you get x equals 3. Add a 1, you get x equals negative 1. Both of these answers, these are the roots, the zeros, the solutions, the x-intercepts of this quadratic. Okay, our last example, it's a little bit trickier. Correct? We have a 2x squared. Well, to complete the square, you cannot have a coefficient on your x squared. Luckily for us, every term can be divided by 2. So we're going to do that first. So if we divide everything by 2, we would get x squared plus 10x minus 4 is equal to 0. Now previously, this number, I call this the junk number. Why is it a junk number? Because this is not a perfect square trinomial. So this is a junk number. I'm going to add it to the other side and get it out of there. So I'm going to rewrite x squared plus 10x is equal to 4. And when I do that, I left a space for my perfect number, which will be half of 10 is 5, squared is 25. So if I add the 25 in there, I'm going to add the 25 here. Now we factor x squared plus 10x plus 25 factors into x plus 5 quantity squared. This is equal to 29. Now we take the square root of both sides. And we would have x plus 5 is equal to plus or minus square root of 29. So since the square root of 29 is an irrational number, I'm going to leave it just like that. We still can solve this both ways. If you think that, let me write it up here, x plus 5 is equal to the square root of 29, or x plus 5 is equal to the negative square root of 29. Subtract 5, we have x is equal to negative 5 plus the square root of 29. And that's how these numbers are usually written, with the whole number first and then the radical second. And here if we subtract 5, x is equal to negative 5 minus the square root of 29. And that's exactly as we will leave them. Now in your textbook, some of your answers will have a decimal approximation for this. You should know how to leave it. This is exact. A decimal approximation would be finding a decimal for a square root of 29 and then doing the math here. All right. Let me know if you have any questions. It's a little bit tricky, but I hope you enjoy.